Okay. All right. Well, today I'm planning to do a review session. All right. And so, this, I want it to be helpful and useful for you guys. So if you have questions and things of that nature, don't hesitate to ask a question in the chat or unmute yourself or anything like that. Okay, so why don't I go ahead and start talking about the midterm exam. I've already given some details regarding the logistics of it for Friday, and basically you can either take it at 10 a.m. or 8 p.m. and I'm asking you guys to log into Zoom with your cameras on, and then you will take the exam on Ccle. It'll be all multiple choice. Okay. So let me, so I do want to just kind of clarify. So, so the exam will be a mix of kind of calculation and definition / conceptual questions. I think I talked about this on Monday. And I have posted practice problems on Ccle, but those practice problems are mostly calculation-based questions. Okay. Yes, you will log, regarding the Zoom link, you just use this class Zoom link. I'm not going to make it any different or anything like that. So, so the exam will be all multiple choice. There'll be a mix of calculation-based questions and some definition / conceptual questions. Okay, and then I'll say the practice problems on Ccle are calculation-based, are the calculation-based questions. Okay, questions. Are we allowed to use online resources like online notes / Wikipedia, and how many questions in total are expected? Okay, so the exam is open note, open book. Okay. The exam is open note and open book. Okay. Okay, and you can use any calculator. Any calculator, even R for calculations. Okay. You are not allowed to talk to other students. Okay. If you and a roommate or you are living with somebody who is also taking the exam at the same time, please make sure you guys are separated, okay? If you've got different rooms or things like that, don't take it in the same room as someone else who's also taking the exam. Okay, you're not allowed to talk to other students. Please do not be in the same room as someone else who's also taking the exam. All right, let me answer these questions here. Okay, so so are you allowed to use online resources? There is no ban against Wikipedia, so I'm not going to explicitly outlaw it, but I doubt that it will be helpful. Okay, so I'll ask some kind of, I might have a definition / conceptual based question, but the answer to it will generally come from my notes. I don't expect students needing to look up answers on Wikipedia. Online notes, if you're talking about the notes that I've given to you in class on CCLE, those are certainly allowed. How many questions in total are expected? I'm expecting somewhere between 50 to 60 questions. To 60 questions, okay. Is there a good place to find practice conceptual definition problems? I would say the homework textbook homework problems. There's a mix of kind of conceptual / definition based questions in the homework textbook. Okay, so kind of yeah, I guess tips for study would be go over the homework problems. And then another one would be to kind of create an abbreviated sheet of notes. Okay. So one issue with having an open book exam is that sometimes students don't take the time to I don't know, write notes or summarize ideas or things like that. And you know, the notes, the PDFs I give you are, say, you know, they're pretty long, you know, 50, 70 slides, 100 slides, things of that nature, 50 to 70 slides. And so, you know, that's like hundreds of slides that you'd have to flip through. My recommendation is to go through those lectures and then create kind of a, you know, a sheet, maybe 2 sheets of notes that kind of summarize things, and then and you can say, you know, more detail on this page of the PDF, and that way, if you need more details on the on a certain subject, you can locate it quickly in the notes. What you don't want to have is you don't want to have 5 files open and then have to arrow key through, you know, 40 or 50 slides to find what you're looking for. Okay, so creating an abbreviated sheet of notes so you do not have to go through you know, 5 PDFs of kind of 50 plus slides. Okay, question. If we use R to find an answer like the correlation coefficient or standard deviation, will we have to write the code we use? Oh, well, it's multiple choice, yeah, so, so no. Okay, will the final have similar questions? I assume you mean midterm exam. Will the midterm exam have similar questions that we have worked on the grade scope quiz? Okay, not sort of, not really. I don't know. Like, so you've had a few pages of grade scope quiz questions, and some of them might be similar to questions on the midterm, but others will be different. So I don't know how to answer this, because everybody has a different working definition of what similar means. And so, I don't know. You know, I mean, just the very fact that Gradescope is open-ended and the midterm is multiple choice, you know, might mean that it's not similar at all. And then, but, you know, is it similar in the fact that they're all, you know, it covers material from chapters 1 through 6? Yes. You know, am I going to ask any of the same exact questions? No. I don't know, you know, similar is too vague of a word to give a good answer about, so I'm sorry. I don't know if I can give an appropriate answer there. Okay, so this is just some general information about the midterm exam. I don't know, do you guys have any questions regarding this? Okay. You have some questions with the practice problems. Okay, yeah. So, so with the remaining time, I was just planning on doing some additional problems from the textbook. And if you have questions from the practice problems that I've posted online, I'm happy to go over those as well. So, yeah, I want to make this time useful for you. So please don't hesitate to post any questions. So go ahead with your question from the practice problems. Let me go ahead. Which file are we talking about? Chapter 4, sure, okay. And question 10, okay. All right, so question 10. So question 10 says, for the following pair of numeric variables, annual income and net worth, value of all assets, we would expect the correlation to be, okay, annual income and net value. You know, I mean, I guess there's a little bit of a judgment call here, but what is your oops, what is your guess here? Okay, for A, put positive and strong. Okay, I mean that's reasonable. I would probably go with positive and moderate. Okay, so positive and strong. Okay, so let's, I guess let me bring up this this thing. Here. Okay, and I sure hope that the answer that I'm picking here is the answer that shows up in the practice answers. Chapter 4, positive and moderate. Okay, it's B. Okay, yeah, that's what I would also choose. Okay, so yeah, the answer I wrote is, in general, we expect people with higher annual incomes to have a higher net worth. That I think that makes sense, right? But the predictive power of annual income for net worth would not necessarily be very strong. And I think this is still a reasonable answer, in that, you know, you can have two people that have the same income, and are they going to have the same net worth? And I would say the answer is going to be no, right? If you have a strong relationship, then that means everybody who has the same annual income should have about the same net worth, or that, and I think we can all say that that's not going to be the case, right? So if the relationship were positive and strong, then this means two people with the same annual income are expected to have the same, very similar net worths, right? Right. So that means, you know, if two people make, say, $100,000 per year, you know, what's their net worth? And the issue with this is that you're going to have some people who just started their careers, right? So perhaps, you know, if you once you graduate, you might find a job that pays $100,000 right out the gate, okay? But what is your net worth going to be? Your net worth's not going to be that much, okay? Because you just started your career, right? And then you have people who've been alive for many years, and their annual income is 100,000, and their net worth might not necessarily be might be much higher because they've been around for a lot longer. Okay. In general, we would expect, however, net worth to have a positive relationship, that people who have been who make higher income to have more net worth than those who are lower income. But yeah, it's going to be. I don't know if the relation. I wouldn't say the relationship is strong. Okay. Chapter 5, questions 6 and 8. Okay, so it says, so in the test, should we use the reasoning of two people having the same or similar results? Yeah, I think in general, that would be a good, kind of a good guidance for is the relationship strong or weak? Because the idea of strong or weak is there a lot of scatter, meaning for kind of values for a certain x, is there a lot of scatter between them, in that are the values different from each other, or are the values similar to each other? Okay. Okay, chapter 5. So this was chapter 4 review. Okay, so we'll take a look at the chapter 5 review. Oops. All right. So chapter 5, we've got problems 6 and 8. Okay, so go ahead and get this. Okay. Let's say the probability of winning a random game of chance is 0.67, and you choose to play 3 independent games. What's the probability of winning at least one? Okay, so right off the bat, we can just eliminate 2 that have answers over 1.0, right? So probabilities have to be less than 1. Okay, 3 independent games. What's the probability of winning at least one? So at least one is the complement of 0. Okay, so either we will win at least one or win none. Okay, so we're going to say the probability of win at least one is going to equal to 1 minus the probability of winning 0. Okay, so if we're going to play 3 games of chance, this is going to be 1 minus the probability of lose, lose, lose. Okay, if probability of win is 0.67, the probability of a loss will be 1 minus that, or 0.33. Okay, so I'm going to have probability of 0.33 times 0.33 raised to the 3rd power. Okay, so what is that? Let's go ahead and okay, so I get 0.964. That's going to be our answer here. So, okay. All right, and then question 8. Sure, let's go ahead and do this. Okay. The event A and the complement A of A are 2 events that are, okay, and so the answer there is these 2 are going to be mutually exclusive, right? So, so basically, the diagram, this is kind of, you have A inside the circle and then A complement outside the circle, okay? They are mutually exclusive, okay, in that both cannot happen at the same time. Both A and the complement cannot happen at the same time. Which makes them mutually exclusive. Okay. They're not independent because if you know one has happened, then that will affect kind of your answer for the probability of whether the other one has happened or not. And so there we go. Okay. And then these things, this is just made up. I don't even know what probabilistically counterbalanced means. That's just a made up phrase that sounded like it could be an answer. And unrelated, they are not. They are certainly, you know, one is the complement of the other. All right, will we be able to print the exam off Ccle? Not easily, I don't think. I don't know how well Ccle prints things. So the exam was not meant to be printed. I mean, you can try printing it, but I'm not sure how it will look printed. I don't think Ccle quizzes print very well in particular, but it might. Okay. Would it be possible to upload a PDF to the exam questions? You know, I'm not. I don't have a way to do that easily. Okay, because so one thing is that the Ccle, one of its features is that it shuffles up the questions and answers. Okay, so just so that people will kind of, just so you, in case people decided to cheat or something, it's not going to be as simple as saying, hey, what was the answer to question 3? And the answer to question 3 is going to be A for everyone. It's going to be kind of like it mixes up the order and it mixes up the answers. And so if I uploaded a PDF of the exam questions, it will not necessarily match kind of the quiz that gets generated by Ccle. So all the questions would be the same, but they would be in different positions and the answers would be in different positions as well. So it's like I don't think I can do what you are asking me to do. Would it make sense if the question asked for at least 2 games, and then what would you do then? Okay, so all right, I think we're referring back to question 6. So let's say the probability of winning a random game is 0.67, and then we're going to say what's the probability of winning at least 2 games? Okay, so sure, we can do that. So the probability of win at least 2. So this becomes a little bit more complicated. Winning at least 2 games. Now we have to kind of rely on a little bit of chapter 6 knowledge from the binomial. So win at least 2 games means we win 2 or win 3, okay? Because we're playing 3 games total. So at least 2 games means we win 2 or win 3. It's not possible to win 4. It's not possible to win 2.5. So we either have to win 2 or win 3. Okay. Maybe I should do a new slide of this. I don't think we're going to figure it out. So we'll leave off kind of the earlier problem. The probability of winning is 0.67, and we want to know what's the probability of winning at least 2 games. And so probability of winning 2 or winning 3 is going to be winning 2, probability of winning 2 games plus the probability of winning 3 games. And technically, whenever you have an OR, you're also supposed to subtract any overlap. So this would be the probability of winning 2 and winning 3. But this is 0. You cannot win 2 and win 3 at the same time. So this is 0. Winning 2 and winning 3 are mutually exclusive. You cannot both win 2 and win 3 at the same time. Those are 2 different outcomes. Okay, so the probability of winning 2, we'll use the binomial. These are, and so this will be 3 choose 2, the probability of winning, 0.67 raised to the 2nd power times the probability of losing, 0.33 raised to the 1 power, right? So if we recall, binomial is n choose k, the probability of a success p raised to the k times the probability of a failure, 1 minus p raised to the n minus k, okay? Plus the probability of winning 3. I mean, we could do binomial, but this is also going to just be the probability. So we have to go win, 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 which is just going to be 0.67 raised to the 3rd power. Okay, so the answer here, 3 choose 2 is 3 times 0.67. I mean, I could do, show you this, times 0.33. So this is 0.4441. Plus, let's go ahead and do 0.67 raised to the 3rd power, 0.3008. Okay, and let's go ahead, 0.4444 plus 0.3008. What is that? 0.7452. All right, so close to 75%. Is that all right? For the question of, the question for winning at least 2 games. What is the probability of winning at least 2 games? We play 3 games. Okay. Okay. Great. All right. Did anyone else have any specific questions? I'm happy to continue just doing a handful of problems and whatnot. Generally, at this point in the quarter, you know, if I asked students what topics do you feel least comfortable about, the general answer is chapters 5 and 6, the probability and the probability distributions. If you feel like you've got that mastered, then you can let me know and we can do different problems. But if you want me to go over chapters 5 and chapter 6 questions, I'm happy to do that. I'm happy to do any problems from throughout the textbook. But I thought, well, if you don't have any specific questions in mind, I can go ahead and start working through just an arbitrary assortment or selection of questions. Is that all right with you guys? Okay. Can we focus on chapter 6? Sure. Yeah, we can start with chapter 6, and then if you guys feel good on chapter 6, we can go back to chapter 5. Any of that stuff, okay? And again, if you get specific questions in mind, just let me know. All right, let me, whoops. Okay, so here is, stop doing that. It's Windows snapping business, okay. 6.24, sure. All right, so chapter 6, I think we're around here. Okay, so this is from chapter 6, and we're looking at extreme negative z-scores. Sounds ominous. Okay. Go ahead and we'll start here, and then yeah, we'll work through a bunch of these types of questions. Okay, so for each question, find the area to the right of the given z-score in a standard normal distribution. Okay. All right. In this question, round your answers to the nearest, what is that, 10,000th or no, 1,000th decimal place, three decimal places. Include an approximately labeled sketch of N01 of the N01 curve. Sure, okay. We'll go ahead and try that out. All right, so our first one, we'll do this, and okay. And okay, so the idea here is if we go 0, and we got -1, and -2, and -3, you know, we're getting most of it, okay? And now we go down to -4, and we want everything to the right. Okay, so we're gonna go right there. And so the answer should be, before we even look at a table, okay, we know the answer should be close to 1. Is that okay? All right, so let's go ahead and we'll go to our, we'll go and download our reference table, okay? And when we go to the reference table, we go, oh, you know what? The smallest number I can find, or the most negative number I can get, is negative 3.49, and it goes to 0.0002. And after that, then we don't have anything, okay? So, but actually, there's this over here, and we're at negative 4.0. It says it's 0.00003. Okay, so I'm gonna copy this little thing here. Okay. So this is from the Z table. These are kind of some extreme values. Some values. Okay. All right, and so basically at negative 4, then this area over here is going to be 0.00040 317, which means this side is going to be 9999683. Okay, and so if I were to round to the nearest third decimal place, okay, this rounds to 1.000. It's not exactly 1, but it's going to round to 1. Okay, so our answer there is going to be 1.000. Okay. And if I just do this again with part B, you know, the issue just gets more and more crazy. So now we're like, this is a terrible picture. Okay, so this is our normal curve, something like this. Okay, again, we're centered at 0. We can go to -1, -2, -3. Okay, and at -4, we're pretty much getting 1, but the thing is asking us to go even further out to 5, 6, 7, and 8. Okay, -8. All right, how much have we shaded in? We're going to be shading even more. Now the total area is 1, so you know, how much more can we get? Well, it's just going to get like, the area to the left of -5 is even closer to 0. It's not exactly 0. Okay. Do these things not add up? 1 minus 0.0000317, 9999683, right? Okay. Yeah, so that's what I got here. Okay. And so if we do -8, we don't even have it here, but but the answer is also going to round off to 1.00, 1.000. Okay. If you had the exact probability for these right proportions, which would be the largest and which would be the smallest? Okay. So, I mean, is this okay that I'm writing 1.0 for all of these, at least rounded? Rounded. No, they're not exactly 1, but they're rounded off to 1. Okay. If you had the exact probability for these right proportions, okay. So, and then yeah, see the plot's even more ridiculous in that, like, I don't know, why would we even go out to, like, if I have 0, I got to go -1, -2, so on and so forth, -3. Dot, 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 and then now we're at -30, okay? Whereas, like, you know, pretty much the, we've got this line that's pretty much at, something, what's going on with my pen here? Something pretty much asymptotic after this point. So pretty much the amount that I've shaded in here is pretty much practically 0, but it's not exactly 0. So area to the right of -30 is even closer to 1 than the area to the right of -8. Now, both of them are pretty close to 1, but one is going to be more extreme than the other. I think let's just check what R has. I think R is going to tell me that at negative 30, the area to the left is 1. But let's see. Okay, so if I do a P norm of negative 8, it's going to give me a value very close to 0. Okay, yeah, it gives me. So let's see. All right, if I do P norm negative 4, I get 3.167 to the negative 5. Okay, which is what we get. Okay, P norm negative 8. This is E negative 16 means 10 to the negative 16. It means I've got basically 15 zeros before the 6. Okay, so the answer here, if we were to shade in this area, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then the first number is going to, and then we'll have 622. Okay. So this side over here is going to be 0.99999, you know, dot, 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 99. And then to make up the regulars, the 622, we're going to have 378. Okay. You know, 15 nines before we get to that 3. Okay. And then for negative 30, I don't even think the computer can represent a number that small. Let's just see. So P norm negative 30. I think the computer just says that's 0. Oh no, look, it got it. It says it is 10 to the negative 198. Okay, so you know the area over here is almost 0. It's what, 4.98 times 10 to the negative 198. I don't think we have anything on the scale of the universe that can communicate how small 10 to the negative 198 is. Atoms in the known in the universe. What is this? 10 to the 78, okay? There are somewhere between 10 to the 78 and 10 to the 82 atoms in the known observable universe, right? So we know atoms are tiny, and we know the universe is big, and if we counted every single one, or something between 10 to the 78 and 10 to the 82, and here we're on the order of 10 to the negative 198. This is magnitude's bigger. Okay, so anyway, magnitude's even more smaller, I guess. Okay, what is the area, equal area in part B? The area to the left of 8 or the area to the right? Huh? What? Which is equal to the area in part B? The area to the left of 8 or the area to the right of 8? Oh, okay, okay. So the area to the left of positive 8 is going to be equal to the area to the right of negative 8. So left of 8.0. Okay. All right. Can we go over 6.11 from the textbook and homework? Yes, absolutely. Any problems you want to do, let's do them. Okay. Yeah, so as far as the homework goes, I've been assigning odd numbered problems because the odd numbered problems, I believe, have answers in the back of the textbook. So you know, if you want me to do any of those problems, I can do them, but I can also do the even numbered problems as well. All right, it says Eric wants to go skiing tomorrow. Oh, so I don't know which version of the textbook you're using. This is the one I'm using here. Eric wants to go skiing tomorrow, but only if there are 3 inches or more of snow. According to the weather report, any amount of new snow between 1 inch and 6 inches is equally likely. I don't know what kind of weather report this is, but so this is what our probability density curve, and find the probability that the new snow depth will be 3 inches or more. Okay, so the answer to this question relies on the fact that anytime you look at a probability density curve, the total area must equal 1, okay? So all we know is that this is the total area is equal to 1, all right? So what we have is we have a width, okay? Width equals 5, and basically the height, well, it's also given in this plot, is equal to 0.2, because we know, right? So 6 minus 1, that's a width of 5. The height is has a height of 0.2. Okay, and so now we want to find the probability that the new snow depth will be 3 inches or more. Okay, so I'm going to go ahead and draw a line right here. Okay, and we want the area to the right now. Will this even work? Oh, look at that, it did. Okay, so what is this area? Okay, what is this area? This area has a width of 3 and the height is 0.2. So the area is going to be 3 times 0.2, which is equal to 0.6. Okay, and so the probability that the snow depth is greater than or equal to 3 is going to be 0.6. All right, can we go over the third 73D in the third edition of chapter 6? Let me see if, I might not actually have that. All right, I'm afraid I don't have that question. Do you have that textbook? What's the name of the problem there? 73. Chapter 6, 73. You can send a picture of it. Okay, yeah. Send me a picture of that. Cell phones. Okay. Yeah, unfortunately, I don't have that. I don't have that textbook with me. So send me a picture of it. We'll and we'll answer it. Okay. Any other questions for the time being? Let me see if I got this. Okay, I haven't received the. I don't know if okay. For the well, let me see. There's probably something similar to that problem. Okay, 5.3 from chapter 5. Sure, we can do that. 315. Okay, let's go to 5.3. Is it empirical versus theoretic? All right. Monopoly player claims that the probability of getting a 4 when rolling a 6-sided die is 1 in 6 because the die is equally likely to land on any of the 6 sides. Is this an empirical probability or a theoretic probability? Okay. Here, let's go. Yeah, let's just do all of these ones. Okay, so this is based on, there was no experiment. Okay, so this one's theoretic. Okay, no experiment. We used kind of intuition. I guess used, the answer in the back of the book says empirical. Okay, well that's wrong. Okay, so there's no experiment, and we kind of used kind of logical reasoning. Okay, we'll just quickly go through these ones. Okay, a person was trying, yeah, sometimes the book is wrong. I don't know, bad editing. Okay, there. Okay, a person was trying to figure out the probability of getting 2 heads when flipping 2 coins. You flip the two coins 10 times and 2 of these times. Okay, so this one is empirical because he did an experiment, right? This is based on an experimental thing. Friend flips a coin 10 times and says that the probability of getting a head is 60% because he got 6 heads. So this one's also empirical because it's based on an experimental outcome. All right, and a magician claims that he has a fair coin because both sides are equally likely. And he tells you that if you flip the coin 3 times, the probability of getting 3 tails is 1/8. And this is going to be theoretical, okay? Because all we're doing is we're doing 1/2 times 1/2 times 1/2, which is 1/8. And we're basically just using logical or mathematical reasoning here. We didn't actually conduct the experiment. So those are all. So those are the answers. If the book said this, then the book was wrong. Okay, I don't think I've received this. Picture yet. Okay. Can you email me the question? Can I? Yeah, you can email me the question, and that's fine. Okay. All right. Let me just try like another problem here. Here, I can do. Will you tell me, is this problem similar to? What if I do this one on internet access? A 2013 Gallup poll indicated that about 80% of US households have access to a high-speed internet connection. I don't know, did anyone have questions on something? All right, and then it says, suppose 100 households were randomly selected from the US. How many of these households would you expect to have a high-speed internet connection? Okay, so here, all right, this is we're going to have to assume each household is independent, but basically we have a binomial problem. Okay, and the probability of high-speed internet, P, is going to be 0.8. And 100 households, we have N is equal to 100. Okay, and so how many would we expect? This is basically asking for the mean. The mean is going to be N times P, which is 100 times 0.8, which would be 80. We would expect 80 households to have high-speed internet. Okay, so I don't know what counts as high-speed internet anymore, and this was 2013. It's 2020 today, so I don't know. Okay. The question is, how do I know it's a binomial problem? Okay. How do I know it's a binomial? Okay. Well, if we tried to answer it any other way, I think we would run into problems, right? So, well, one thing is if we just said, okay, well, this is a probability problem, right? So, you know, P is equal to 0.8, and then we're talking about 100 households. Well, so far we haven't asked any question. There isn't a question so far, like what's the probability that if I pick 2 houses, both of them have high-speed internet or something like that. That's not a question that was asked, and so you know, if that were the case, then it could just be approached as a regular probability problem. But here we're asking, we're telling you how many there are, and and then we're asking kind of an expected number. So we're asking for a mean there, okay? Okay, yeah, 6.73, I just received the question here, and the question is also similar here. Let me do the rest of 674, and then we'll let me do we'll also get this question that that I was emailed here. Okay, all right. It says if 10 households are selected randomly, what's the probability that exactly 6 have high-speed access? Right. Okay. So here, this again is binomial. This time, n is equal to 10. Our probability is still 0.8, and we want 6 with a high-speed access. So we're going to say x is equal to 6. All right. So we can answer this using the binomial. We can do 10 choose 6. 0.8 raised to the 6, which means the number that don't have internet access, all right, which has a probability of 1 minus 0.8 or 0.2, there has to be 4 of them, okay? And so, so the answer to this is going to be the answer to that. It can also be answered using R, using D binomial. And we have 6. So when you type in D binomial, it's going to say X size and probability. So we have 6 out of 10 with a probability of 0.8, and we get 0.6, 10, and 0.8. And the answer is 0.088. If I did these calculations, okay, 10 choose 6 times 0.8 raised to the 6 times 0.2 raised to the 4, I'll also get 0.088. Okay. All right. What is the probability that 6 or fewer? Okay, so this gets annoying. Okay, 6 or fewer means x is equal to 6, 5, 4, 3, 2, 1, or 0. Okay, and so that would mean I'd have to do 10 choose 6, 0.8 to the 6, 0.2 to the 4, plus 10 choose 5, 0.8 to the 5 times 0.2 to the 5, plus so on and so forth, all the way down to 10 choose 0, 0.8 to the 0, 0.2 to the 10, okay? I can also do D binomial, make my life a little bit easier by D binomial 6, 10.8 plus D binomial 5, 10, 0.8, and so on and so forth, okay? Let's see, okay. After this, can we look at chapter 5? Okay, so let me do the question 73, which is similar but different, okay? For another question, for or fewer questions, binomial questions, is that the binomial CDF on the calculator? Yes, I believe. If I did this, I could do D binomial, 6, 10, 0.8. I can also just do 0 through 6, 10, 0.8, and R will calculate all of this, and I can do the sum of this, and my answer is around 12%. In R, I can also do P binomial, which is the binomial CDF, and we will get the same number here, okay? And then, and I think if you enter this into your calculator that has the binomial CDF, you would also get this answer. But this is kind of a tedious question, and I will not be so mean on the exam to ask this, okay? So if I said that like something or fewer, it'll be something like 2 or fewer, where you only have to do 0, 1, or 2. Okay, can you explain why we have to count down in that way? So 6 or fewer, versus like counting down versus counting up. You could count up. You could go 0, 1, 2, 3, 4, 5, 6. That would be the same answer. Here I counted down 6, 5, 4, 3, 2, 1, 0. I'm not sure if that was the question you're asking. But 6 or fewer means 6 or anything less, right? 6 or anything less. So you have to do all of those. Okay, let me do the question that I got in my email. So let me just. Okay, so we'll resume here, and let's see. Okay, so here's 6.73. I'm gonna kind of just go through these quickly. Wait a second, I just lost my chat window. All right, it says 52% of households have no landline and only had cell phone service. Suppose a random sample of 40 households is taken. I think this number is higher today, but let's see. Okay, so we've got n equal to 40, and here p is equal to 0.52, and find the probability that exactly 20 of the households sampled only have cell phone service. Okay, so again, this is a binomial problem, and we're going to do 40, choose 20, and the probability of having only cell phone service is 0.52, and that means 20 of the households have to fit that criteria. And then the probability of not having only cell phone service is 1 minus that, 1 minus 0.52, or 0.48. And if we have a total of 40 households, then that means we're going to have 40 minus 20, also another 20 here. Okay. Fewer than 20. Fewer than 20 means x is equal to 0, 1, 2, all the way up to 19. Okay. And so, so this is kind of, this is annoying, but basically you would have to use a calculator or computer. And then so we want the cumulative. So you could use the Binomial Cdf with a 19, okay? Or you can use P binom 19 out of 40 with a probability of 0.52, okay? I think you covered the use of P binom in your lab. Am I mistaken? Maybe? I don't know. Okay, at most 20. So this is all like a little bit of like language gotcha things, okay? So at most 20 means x is equal to 0, 1, 2, all the way up to 18, 19, and including 20, okay? So the answer, the difference is going to be this. It's going to be P binom plus whatever part A is, okay? So answer to C is going to be part B plus part A, or you can just get it with P binom 20, 40, comma 0.52. Okay, so it's the probability of getting 19 plus exactly 20. So answer is part A plus B will equal part C. Part A plus part B will equal part C. Okay, find the probability between 20 and 23 households. So this is a little bit ambiguously written. Between 20 and 23, I don't know if 20 and 23 are included or exclusive. Okay, so if it's between inclusive, then that means x is equal to 20, 21, 22, or 23, and you would have 40 choose 20, etc., plus 40 choose 21, 0.52 to the 21, 0.48 to the 19, plus so on and so forth. 40, choose 22, et cetera, plus 40, choose 23, et cetera, okay? And then between exclusive, means x is equal to 21 or 22 only. For 73D, why can't we do binomial CDF for 23 and 20 to find the probabilities and then subtract the probability of 20 from 23 like we did for the heights? Okay, so the issue here, so you can do something like that. You can do something like that, except you have to do 24, all right? So the issue is you have to imagine we've got 20, 21, 22, 23, 24, and oh dear. What is going on with my pen? Ah, stop. Okay, so, oh, and then let's also go down to 19. Okay, so the binomial CDF is technically like these lines, okay? So I don't, I don't know how tall these lines are, right? But let's just say we've got these lines, and we want basically the height of we want these ones, okay? Okay, we want if we're doing the if we're doing inclusive, we want these ones. And if we're doing exclusive, we only want 21 and 22. Okay, so let's say we're doing this, okay? All right, so what we can do is to get these things, all right, we can do the 24 minus the 19. So you can do binomial CDF of 24 minus binomial CDF of 19. That should work. So I can do P binomial 24, 40.52 minus P binomial 19, 40.52. This should equal the same as D binomial 20, 20 through 23. 40.52, summed up. These should equal each other. We'll try it out real quick. P binomial 4. I'm happy to answer these questions. I think we're making we're asking some questions that I have no intention of asking anything this challenging on the exam. I don't know if that's a comfort to you, but you asked, and so I feel compelled to answer them. Oh, shoot, what did I do? 20, 21, 22, 23, 24. Why is my number? Oh, you know what? I wanted the 23. Sorry. Not 20. It's 23 minus 19. Sorry. I messed up there. And the reason for it, I know my mistake. Okay. So we want the 23 minus the 19, not 24 minus 19. Okay. Because we want the 20, we don't want the height of the 24, okay? So so you have to kind of imagine you have all of these sticks laying out, that there's like 40 sticks and the total length of them is 1, and we want the length of these sticks going from say 20 to 23. And so we have to remove the 19th stick and lower. That's all. Okay. All right. So sorry. But anyway, I'm not going to ask anything this complex on the exam. Like if I ask something where I do a binomial where you have to do multiple of them, it'll be like 2 or less. Okay. And then you add 0, 1, and 2 and things like that. Okay, is the exam going to have a fair share of questions from each chapter, or should we expect some chapters to have more questions? I've tried to balance the exam to be to cover the different chapters to have each of the chapters represented. You know, please don't like go through and count and say like you had 55 questions and you know that you should have had 8 questions from each chapter or something, you know. That I don't know if it's down to that level of precision, but I do try to have each of the chapters represented on there. So so I don't think any one chapter is that much more represented than any of the other chapters. Okay. All right, and then we had a question from chapter 5, problem 65. So let's go ahead and jump over there. Okay, so here we're looking at recidivism. Florida's recidivism rate is 33%. That seems really high. That means about 33% of released prisoners end up back in prison within 3 years. Oh my goodness, okay. Suppose 2 randomly selected prisoners have been released, who have been released are studied. Okay, what is the probability that both of them go back to prison, and what assumption must you make to calculate this? Okay, so we'll go ahead. I hope this is the question you were asking, Alma. Is this right? Let me know if I'm answering a different question that you did not ask. Oops. Okay. All right. So so we've got. Oh, what's wrong with my pen here? Okay. So we have p equal to 0.33. All right. And sorry, I'm experiencing problems here. Okay. Oh, so part C is the particular part of the question. What is the probability that at least one goes back to prison? So this, I would say, you know, regarding the level of difficulty on, you know, this could be treated as binomial or as a regular old probability question, and I'd say this might be kind of the level of difficulty regarding types of things here. Okay. What is the probability that both of them go back to prison? Okay. So here we would do 0.33 times 0.33. Okay. And I don't know what that is. 0.33 times 0.33, 10.1089. Okay. And then we must assume they are independent. Okay. I mean, this technically could also be treated as binomial. Okay. You could do it as n equal to 2. So let me just write this out, okay? Could also be binomial. And you're going to get the exact same answer. You can do n equal to 2, p equal to 0.33, and x, in this case, both go back to prison. X will be 2. And so you would have 2 choose 2, 0.33 raised to the 2, and 1 minus 0.33, which will be 0.67. raised to the 0. And when you do this calculation, you're also going to get 0.1089. Okay, so if you do d binom 2, 2.33, you get 0.1089. Okay. What is the probability that neither of them goes back to prison? So B will be 0.67 times 0.67, okay, which will be 0.67 times 0.4489. Okay, and then C, at least one. Okay, so at least one is the complement of 0. So this is going to be 1 minus the probability that 0 go back, which will be 1 minus, so neither of them goes back to prison, we found to be 0.4489. And that's going to be 0.5511. 0.5511. Okay. You can also treat at least one as equal to 1 or 2. Okay. 1 or 2 go back to prison. So 1 would be 2 choose 1, 0.33 to the 1, 0.67 to the 1, plus 2 choose 2, which we've done here, 0.33 to the 2, 0.67 to the 0. We know this one from before is 0.1089, and then if I do this calculation, I can just do d binom. I'm going to just cheat here and do d binom 1, 0.4422. And 0.4422 plus 0.1089 should be exactly 0.5511 as well. 0.4422 plus 0.1089, 0.5511. Okay, so there's multiple approaches. So when you see at least one, you can just treat it as a complement of 0, and I think that's kind of the easiest approach. I mean, for me, because I remember that complement of 0 means at least one. But you can also treat it at least one means one or more. And in this case, if we're talking about 2 people, it's going to be 1 or 2. And that would be the way to approach that. Okay. All right. Is this all right? Any other questions here?
Professor, actually, I think my book was like a different
Oh, you had a different book. Okay.
Yeah, no, but it's I think it's because it's the international version, but it was the same type of question, but it just asks what is the probability that at least 2 go back to the prison?
What is the probability that what?
At least 2. So it made us choose 3 random selectively prisoners, and then what is the probability that at least 2 of them go back to prison?
Okay. So it's the same problem, but okay, this time n is equal to 3, and then the question's probability of at least 2. Okay, sure. So we got p equal to 0.33 or whatever it might be. Okay. So here, if n is equal to 3, at least 2 means 2 or more, which in this case is going to be 2 or 3. So now we've got the probability that x is equal to 2 plus the probability that x is equal to 3. And so this one we've got to use binomial. So we're going to do 3 choose 2, 0.33 squared times 0.67 to the 1. Okay. Plus 3 choose 3. I mean, this one technically we don't need to use binomial. 0.33 to the 3rd times 0.67 to the 0. So whatever this number turns out to be. So 0.33 raised to the 3rd, 0.0359. Okay. and then this, you know, I'm going to cheat. Okay, so we'll do D binom 2, 3.33. Okay, 0.2189. 0.2189. And you add those two together. Is that okay? Does that help or?
Yeah, that makes sense. I think it's because we hadn't learned how to do binomials before, so I was doing it like regular probability, and I just got confused with the numbers.
Yeah, you can do regular probability, but then you have to list off all the different possible arrangements. So if you do, so this is why the binomial is helpful, because this 3 choose 2 business takes care of the different possible arrangements. So when we talk about 3 people and we want to select 2 of them, you know, you pick the first 2, the first and the third, or the second and the third, and there's 3 possible arrangements there for selecting people. Okay, can you review some conceptual question examples, please? Oh, okay. I can try, but I don't know if, like, I don't want to upset anybody, because, right, like, I don't want to give you like this exact questions that I'm going to be asking, and at the same time, you know, so I think but yeah, the you know, my recommendation would be to go through some of the homework problems. So let's see if I can pull up, you know, let's just, I don't know what are some good questions here. So often in the homeworks, okay, the beginning questions in each section are usually fairly conceptual in general. So like if you go to the beginning of, say, well, that's not a good example, but like, so if you go to like section 5.2, usually the first couple of questions will be a little bit conceptual, right? So here it'll be like, which of the following could not be probabilities? So anything over 1, anything, so D and C is negative, can't be. D is over 100%, can't be. A, you know, 5, things like this. I don't know if I have good examples here that I feel like I should use as examples here. Okay, can I quickly repeat what is the difference between D binom and P binom? Okay, sure. So D binom is the probability of getting something at exactly. Okay, so D binom. So D binom is written in X, N, and P, and this is the probability of exactly X successes in N trials with probability success P. Okay, and then P binom is probability of at most X successes in N trials with probability success P. Okay, so at most X successes is equal to 0, 1, 2, all the way up to X. And then we add them all together. So that's going to be, that's the P binomial. Okay. Question 631, red blood cells. Sure, let's take a look at that. Red blood cells question. Okay. All right. A normal distribution question. All right. So it says the distribution of red blood cell counts is different for men and women. I didn't realize that. Okay. For both, the distribution is approximately normal. For men, the middle 95% range from 4.5 to 5.7 million cells per microliter. And for women, it's this and this. Okay. What is the mean and what's the standard deviation? Oh, okay. Let's do this. So we have the mean in the middle, and then it says the middle 95% go from 4.5 to 5.7, and so and we want the kind of the middle 95%. So okay, so the mean is going to be exactly in the middle here. Okay, so the mean is going to be equal to 4.5 plus 5.7 divided by 2. We divided by 2, we're going to get 5.1, right? Okay, so the mean is equal to 5.1. All right, so far so good, I think. Okay, and so now what we know is that for the middle 95%, okay, so we have a couple choices here, right? We can just say this is approximately z equal to 2. Z is approximately 2, and z is approximately -2. Is that all right? Okay, and so 5.7 is approximately 2 standard deviations above 5.1. Okay, so basically if I do 5.7 minus 5.1, this is going to be approximately 2 standard deviations, 2s. And so I get 0.6 is about 2s. And so if I divide both sides by 3, I get s of around 0.3 million cells. Okay, because that's the unit that we're using here. All right, if we wanted to be a little bit more specific, okay, we can also say, well, if I want the middle 95%, so this is approximately. If we wanted like a more precise answer, if we want the middle 95%, okay, that means I would have 0.025 in this corner and 0.025 in this corner, and I would go to our Z table. And I would look for the value that's closest to 0.025. Okay, 0.025 is right here at -1.96. So very close to -2, but -1.96, okay? And then the same reasoning would also hold, okay? So I have 5.1, I have 4.5, And, you know, we could do the same thing. We could say, okay, that difference from the mean to where we are, 4.5 minus 5.1 is equal to negative 1.96 times s. And I would get negative 0.6 is equal to negative 1.96 s. And s is equal to, you know, 0.6 divided by 1.96. And I get just something a little over 3.306, a standard deviation of 0.306. All right, is that okay for 631? And you would use the same kind of thing. You would just replace 4.5 with 3.9 and 5.7 with 5.0, and you go through. So the mean is right in the middle between, if they tell you you got the range for the middle 95%, the mean would be right there in the middle, and then you can get that distance and divide by divide by that to get the standard deviation. Okay. Are there any other questions here? All right. Do we feel okay about normal model problems? You can definitely expect some normal model problems here. So maybe I'll just do one right here. 6.34. Nobody asked for it, but I'll just do this. Okay. All right, so we'll say the average reading score was 509. Okay, so we're going to say that the mean is 509. And assume the standard deviation is 100. And SAT scores are normally distributed. What percentage scored 600 or less? Okay. We'll put 509 here in the middle. We're going to put 600, and we want, you know, what is this area over here? Okay, so we want to know what's the probability that the SAT is less than or equal to 600. Okay, so we have SAT comes from a normal distribution, mean 509, standard deviation 100, right? And so we're going to convert this into a z-score. I get negative 0.91, okay? So, so now this probability that SAT is less than 600 is the same as the probability that z is less than or equal to I did this backwards. Apologize. It's your number minus the mean, not the other way around. Um, 600 minus 509, and this is going to be positive 0.91. My apologies. Okay, so z is less than, what is the probability that z is less than positive 0.91? We'll go to the table, and I go to the positive side. Go to the row 0.9 and the column 01, and I get 0.8186. So I go to the table, and then the area to the left. Wait, I think that's right. Area to the left of 0.91 is 0.8186. Okay, and so what percentage? We would say 81.86%. Okay. What percentage of SAT takers in Connecticut scored less than 509? Well, that's easy. 509 is the mean, so this answer is 50%. No calculations needed, right? So this is, we know half score lower than the mean. And the question is, SAT less than 600 is the same thing as SAT less than or equal to 600. Yes. Or at least in this thing when we treat it as continuous. Okay. Technically, the answer in real life is ever so slightly different because your SAT is an actual, like, you can score exactly 600. But we're treating it as a normal distribution where it's continuous, and then the probability is of less than or equal to is will be equal to each other. Okay. Let me see if they're okay. Well, maybe I'll do something like the percentiles. Okay, so this is a related but different question. So make sure you're comfortable going back and forth. So in this case, so here it says the mean quantitative SAT score for male college-bound high school seniors was 530. Okay, and SAT scores are approximately normal with a standard deviation of 100. So here we've got SAT comes from normal with a mean 530 with a standard deviation 100. Okay, and then we want to know what is the 96th percentile. So we want 0.96. All right. And we have 530 in the middle, and we want to know what is this. Okay. So we go to the Z table, and we want to find the Z that gives us a value very close to 96%. And so that answer is going to be 1.75. It gives me 0.9599. So at Z equal to 1.75, the area to the left is equal to 0.9599, which is very close to 0.96. Okay, so I'm going to go ahead and just plug that into what we're dealing with. We got Z equal to 1.75. X is the value I don't know. Mu is 530. And sigma is equal to 100. Okay, so now I got 175 is equal to X minus 530. I add 530 to both sides, and I get X equal to 705. Right? All right, so here we have 705 will be the 96th percentile for SAT scores. Okay, how are we feeling? Is this good? Are there any other questions? Okay, well, I don't know. I mean, I could keep doing more, but I can also just wrap it up here. So yeah, good luck as you guys continue to study. And we will see you guys on Friday, either at 10 a.m. or at 8 p.m. Again, choice is yours. Just log into Zoom, and we will see you guys then. And other than that, have a good day. Stay cool in all of this heat. At least in California, it's been very hot. But I hope wherever you guys are, things are going well. And we will see you guys on Friday. So, all right. Good luck, everyone. And see you then.